Welcome to the next lecture in our comprehensive AI, machine learning and data science course. Yesterday, we had discussed these various applications of data science, in which we had said it is helpful in recommendation systems, it is helpful in credit card fraud analytics, it is helpful in risk analytics and risk undertaking. But now today, let us take actual companies, and these are giant companies of the world. And if they are using data science, and they have been using it since last several years, so obviously our industries in India also must use this. There are companies like JP Morgan Chase who use data science to assess credit risk and manage financial risks efficiently. Now, obviously, if a company is of this level, who actually, if you remember, then during 2008 financial crisis, when one of the largest financial firm of US went bankrupt, then it was JP Morgan Chase who acquired that. And while making such a decision of acquisition of millions or probably billions of dollars, obviously they must have first assessed what are the risks, what are the assets, underlying assets of the company which they are acquiring, and will they be able to turn around even with government support or whatever. But if the company is if there is no hope of reviving that or realizing their investment, then obviously JP Morgan Chase is also a private company, so they would not invest. Then managing financial risks. This JP Morgan Chase is an advisory work as advisory firm, and they also are investors. So in both roles, they have to manage the financial risks while making investment decisions. PayPal. Now PayPal is the oldest internet-based transaction system. Even before this, our Paytm or UPI etc. in India were discovered. At the time, PayPal was the only way in which international transactions could have been done through internet. I'm not talking about Visa and Mastercard, but this PayPal was a boon for small merchants, and their expansion, their operations expand across maybe 150 countries. So you can understand the amount or the number of transactions which they have to handle. And among them, there is only a fraction of or a small fraction which are fraudulent transactions, and they have to handle those in real time. Because after the fraud has already occurred, there is no point. Recovering the money is very difficult. But if the fraud has already occurred, or if the fraud is occurring, and at that time only you can detect and prevent it, then it has some value. Disease prediction. IBM's Watson model, that is the pioneer in healthcare analytics. They leverage data science to predict disease patterns, and also leverage data science to decide treatment outcomes, or what would be potential out of several treatments. Each treatment would give what potential outcome or prognosis, that is decided by this disease prediction models. And IBM Watson was mainly designed for cancer, but nowadays it is also used for many other diseases. Then treatment personalization. There are certain companies like Flatiron. They analyze the clinical data and personalize the cancer treatments. Okay, marketing. Two most well-known and big platforms, Netflix and Amazon, they use clustering techniques, and we are going to learn all this. Clustering, we have taken 4 different types of clustering algorithms to recommend personalized TV shows and movies. For example, if you have watched one horror movie, then immediately next time when you open Netflix or Amazon Prime Video, then they would recommend you similar other shows. If you have watched one documentary or one maybe Oscar winner movie, then they will start recommending several such. If you watch a particular genre, that maybe comedy or horror or romance, then they will start recommending similar other shows. So for that they use predictive analytics. They also Amazon as a online seller. This is Amazon. That was I was talking about Amazon Prime Video, but Amazon as an online seller uses predictive analytics to optimize marketing strategies and increase the customers' engagement. Then supply chain management. Now every business has to employ, every business has to use supply chain. For example, uh, any business has to acquire, procure raw materials, then process that raw material, and maybe semi-processed or completely processed products. It has to send it to the market through multiple maybe intermediaries in between dealers and distributors and all that. So logistic is important. Then, for example, the DHL is one of the world's largest courier agency. So they have to use logistics because that will optimize their routes, improve delivery efficiency. That is, delivery can be given in the fastest possible manner and with least amount of expenses. That is what they use data science for. Walmart. Now, this is a retail giant having operations in more than 180 different countries. They use predictive analytics to manage the stock levels dynamically because the inventory management is very important for these firms. The reason is that if the stock unnecessarily goes on occupying the warehouses, then they have to pay money to those warehouse owners because many of those warehouses are taken on rent. So they predict the demand depending upon seasonality, depending upon whether festivals are approaching or not, and many other factors, so that they have to stock exactly that much amount, and the inventory is not that large, so that warehouses are over crowded. But on the other hand, they also have to ensure that whenever the demand increases, then they should not run out of stock. So both these things can be achieved by predictive analytics. Then government and public services. US government uses data science to analyze social media for public sentiment and aiding in policy making. Now that means that maybe our India, people express a lot of sentiments on social media, but the question is, does the government leverage that information? I'm not talking about leveraging it for individual parties' political gains, but leveraging it for country's benefit. Then US government uses the information on social media and uses it as an aid in policy making. Then resource allocation. Municipalities can allocate public transportation, scheduling, routes, etc. based on data-driven strategies. So at this time in this area, more buses will be deployed or less buses will be deployed. That is decided based on past data. Uber is a private entity, but if Uber success is also because it has optimized the availability of its drivers and the cabs based using data. Then telecommunication. AT&T, one of the giants in the telecommunication, uses data analytics to optimize network operation and service delivery. For example, most of these companies nowadays do not only provide the voice services, but they also provide internet services. But all these companies, if their internet network is capable of serving maybe 500 simultaneous requests, then they will always register say 750 customers, because the assumption is that not everyone is going to use the internet at the same time. So the question is how to decide how many of that 750 are going to use the internet and at which different hours. That numbers will go on fluctuating during daytime, during the business hours, whenever maybe in India IPL final is being played or World Cup final is being played, in European countries when soccer final is being played. So at that time the demand for the connections would rise, but at some other time, maybe during night time, maybe during festival season, Diwali, etc., it is possible that there are less connection requests. So in this kind of situation, dynamically the bandwidth, etc., are adjusted so that maximum number of customers can be served and still everybody feels satisfied. Okay, now you know why the companies, Geo or any other data provider, they write the speed up to 100 Mbps. So up to 100 Mbps is an ideal condition. You will never get 100 Mbps, but that means that if no one else has logged in out of that 750 except you, then maybe you are the only one customer who has logged in. Then in that case, you will get the 100 Mbps speed. Their whole network is capable of providing 100 Mbps speed. In practice, you will get maybe 12 Mbps or 15 Mbps, 20 Mbps, like that. Okay, so that is the situation. Then Verizon employs predictive model to identify at-risk customer and develop retention strategies. Okay, so this is also important. Customer churn analytics, this is called. That again, that is very important because acquiring a new customer is always very costly compared to maintaining your existing customers. So based on customer's behavior, if his engagement keeps on dropping, or maybe he is now logging it less number of times per week, or his purchase value are getting smaller compared to what he was buying per month earlier, it is easy to predict that this customer is likely to churn. Churn means he is perhaps likely to go to your competitor. So you immediately, such companies predict that, and they in advance, even before the customer has actually churned, they in advance offer some maybe discount coupons, maybe some other benefits, so that the customer is tempted to stay with them. General Electricals, one of the largest GE manufacturers of electrical devices, in healthcare equipment also they have a very big market, uses the sensor data and analytics to predict equipment failures before they occur. Okay, so this is that predictive maintenance which we talked in previous lecture. So even before the device is likely to fail, you have to be able to predict that failure is going to occur, because these healthcare equipments are very costly. One MRI machine, high tech MRI machine, may cost maybe 2 crores, 3 crores rupees. So then you have to predict if each part also, its parts are not freely available, just like parts of maybe a popular Maruti car model. So if you can predict in advance when a failure is likely to occur, you can order in advance the part, and your those costly machinery will continue to work. Samsung is using machine learning to detect manufacturing defects. So that also we have seen that anomaly detection, etc., is useful for detecting manufacturing defects. Out of thousands and thousands of pieces, the question is how to, do they evaluate every single piece for quality control, or is there any sample size? So out of maybe 20,000 televisions produced by Samsung, or maybe 1 lakh mobile phones produced by them, do they check each and every mobile phone, or they take some sample? And if they take some small sample, then what are the sampling strategies which they adopt so that their sample, that is that maybe they check only out of 1 lakh mobile phones, they check only maybe 12,000 mobile phones, but those 12,000 must be selected from different batches and different factories, because such companies may do their production at several units. So there should be enough representation of all batches and all different factories, so that the sample is not skewed. If you take all samples from one factory only, then it will check only manufacturing defect from that factory. But what about the defects arising from other factories? Or they take samples at all intervals of time, samples from different factories, samples from different models, and then they check those 12,000 samples. But that ensures that if there is no defect in that 12,000 sample, then there is no defect in all entire 1 lakh population also. And if by chance defect creeps in one or two out of that 1 lakh population, then they will replace that piece. But at least they cannot afford that out of 1 lakh, maybe 2,000 are defective pieces. Or hardly out of 1 lakh, maybe 5 to 10 are defective pieces. So that level of quality control. In education, platforms like Coursera use data science to analyze students' performance and improve the course offerings. Then customized learning experience. Khan Academy uses adaptive learning algorithms to personalize educational content for each student. Now this personalization is the latest craze in education, and people will go on doing this, because the demand for smaller and smaller, or say smaller student teacher student ratio, that is increasing. Earlier, maybe in our father's time, one teacher was teaching 50 students. Now one teacher is teaching maybe 30 students. Next, one teacher, high-end schools, one teacher is teaching 10 students. At PhD level in some of the world's greatest universities, maybe like MIT, Stanford, there is a 1:1 ratio. Okay, so that ratio, or the such personalized content, for how to ensure that for online courses. So online courses continuously go on collecting the user's data, how the learners interact with the study material, whether they attempt meaning the interleaving exercises or small tests before going to the next level in the study material. What is their performance in those intermediate exercises? Based on that, the study material adapts itself. If there are learners are minor, then the parents are also informed by SMS or some other means that your kid is here in this particular part of curriculum. The kid is having problems, so, and or in this particular part of curriculum he has just skipped the lesson and moved directly to the exercises, and the performance in the exercise was not good. So even in online education, it is possible to monitor the learner's performance, just like in offline or classroom education. The teacher goes on monitoring each and every student and goes on giving feedback to the student, goes on correcting him. It is possible to do the same thing using an algorithm. Okay, genomics. Now this is also one big contribution of data science, that analysis of genes. That is the big genome project. We all know that nowadays we know completely about human beings or Homo sapiens the genetic structure, and that has helped in detecting several genetic diseases. Help nowadays we have even reached gene repair therapies, where some of the genetic diseases can be cured, and some of the genetic diseases which are I mean, in your genes, if they are, then they can be predicted in advance so that you can take suitable measure. Okay, and personalized medicine. See, even with allopathy, sometimes same medicine may not work for everybody, particularly for diseases like cancer. So, if based on your genetic information, the medicine or the treatment can be personalized. In environmental science, NASA uses data science techniques to analyze satellite data for climate change research. Okay, and the images of glaciers melting in polar region, because who will manually go in those regions periodically and go on measuring at what rate glaciers are melting, at what rate polar ice plates are melting and everything. So just by analyzing from satellites images, it is possible to get information about that. You get information about the forest cover in various countries, get information about the biodiversity and many other things. Okay, so these things are the uses of data science, which are I have given this time. These also were the uses, but that were industry wise or domain wise, sector wise. While these are actual examples of different companies. Okay, so thank you and see you in the next lecture.